I'm Kristin Laemmert. I'm a Terraform core developer, and I've been working on Terraform for a little bit over 3 years. Now I'm going to forego my usual About Me slide, but I do need to pay the cat tax, so here you go. Now this picture is also a representation of the face I made when I first waded into this topic about a year ago. I've given a handful of talks about various Terraform releases, but this time I get to do something different, a deep dive into Terraform's internals. Specifically, I'm talking about the Provider Protocol. Terraformally speaking, this topic is about version 6 of Terraform's Plugin Protocol, which I added in Terraform 0.15. This new protocol added enhanced modeling of complex attributes. Now, if you're wondering what the heck that even means, it's quite all right. It took me several weeks to fully understand it myself. Really, what I first needed to understand is, what is a block even? So I've got a lot of caveats about this talk. First of all, this is a deeply technical topic. I'm going fairly far into the weeds. This talk assumes that you have basic familiarity with Terraform concepts. You don't need to be an expert, but it's really going to help if you're familiar with Terraform. While I don't assume you're familiar with provider development or the plugin protocol or the SDKs, it is going to help because there's a lot of details I'm covering in this talk. Also, I'm badly oversimplifying everything I talk about today. I've tried really hard to tell no lies, but I'm leaving out details. So if you're looking at code snippets in here, they're probably not going to work. There's pseudocode. So sorry about that. There's just a lot of information. And again, this is just a word-heavy slide. I have text slides and code snippets and configuration snippets. If you're used to my previous talks with all the memes and pictures of my cats, I had trouble fitting them in here. So I'm going to give an outline of what I'm talking about today. There's going to be a bit of a history lesson where I kind of talk about the backstory of the plugin protocol and how we got to the particular issue that I worked on. I'm going to cover some key concepts since there's a lot of details I'm covering. Then I'm going to get into actually what the problem I was trying to solve with Block was and share my solution. Okay, now I've said this is a word-heavy slide, but I did insert some cute images to give us a break between the main topics. So Lauren, this is the piglet you asked for. It's here just for you. Okay, let's get into the history lesson. Before Terraform 0.12, the plugin protocol was a direct extension of Terraform's internals. So changes to Terraform frequently required changes to the protocol. They were tightly coupled. Terraform and the SDK were both very flexible. The SDK would enforce some assumptions, but overall, we'd kind of take whatever providers gave us. The downside of that is that similar results could be obtained in multiple ways, and it wasn't always clear why that was true or which ways were the best ways to get the results you wanted. Some differing assumptions in the upstream APIs began to surface as differences in style between providers. Various SDK features that we'd added over time kind of got combined in new and interesting ways, which led to some complex emergent behaviors. Now, emergent behaviors is my nice way of saying, I didn't even know that was going to work until somebody did it. And we didn't know people were doing it until they depended on it in production. And so these emergent behaviors led to some inconsistencies and to some bugs, although, again, also did a lot of the very cool things that provider developers have done. So it's not all bad. Now, one of the specific examples of one of those weird Terraform conventions that led to issues is that Terraform tended to flatten everything in a resource block into this map string interface. So no matter what interesting data structure you may have in your resource in the provider schema, it all kind of got smooshed down to this one form. Terraform was big on strings before 0.12. If I'm going to oversimplify, I'd like to say everything was basically a string eventually to Terraform. And Terraform handled these things somewhat inconsistently. So sometimes, because of that, things would work or fail depending on how the configuration was written, what the provider expected or assumed. And honestly, some days it just felt like solar flares, like gremlins. We didn't always know what was going on or why. And then Terraform 0.12 came out. Terraform 0.12's major theme, I would call, was directly addressing those issues of flexibility and inconsistency. So that whole problem is what led Martin, and this is back before he was even a HashiCorp employee, to write an entirely new type system, NestedType. This is a consistent representation of dynamic values, so it enforces its own invariants. It has strict types for everything. It also understands the concept of nulls and unknowns. So these are very Terraform-specific concepts. A new type system led to version 2 of HCL. So HCL is the Terraform or the HashiCorp configuration language, which is what the Terraform configuration language is written on top of. HCL2 is able to now retain more specific information about blocks and attributes and all that information into NestedType. So this was now a consistent way to track this information, no matter how you wrote the configuration. Now in Terraform 0.12, we also added a new provider's interface. So the protocol was no longer a direct implementation of Terraform's internals. This made it easier for us to decouple changes in Terraform to changes to the protocol plugin. For Terraform 0.12, finally, not finally, there was a lot more to it, but for this topic, finally, we added shims so that providers written with this new protocol that we introduced in 0.12 could also work in Terraform 0.11. So we wanted to make sure this was backwards compatible so provider developers weren't, again, tightly coupled to providers that would only work with Terraform 0.12 and newer. Now, unfortunately, with all of the shims and the pre-bullet point 0.12 issues I kind of talked about, the flexibility, well, all of these things combined to create a situation where there was no possible shim implementation that could work with both 0.11 and 0.12 and preserve the emergent behavior across all resources and all providers. What I'm saying is that there were consequences of 0.12. All right, now I'm going to get into the key concepts and give an overview of all the technical topics that you need to be at least basically familiar with to understand the talk. Everything builds on each other, but it is deeply technical, so I hope this makes sense. In the Terraform configuration language, our base structure is a block. A block is the container for all other content. So an entire resources configuration is a block. The provider configuration is a block. Your backend configuration is a block. Arguments assign values to names. They appear within blocks. Fairly simple. These are the key Terraform concepts. So to take a look at this in a configuration file, I have a Happy Cloud Server resource. So this entire thing is a block, the whole resource definition. Inside that block, I have arguments. Here I have image, which is an argument. This is image as a string. We also have the tags argument. We also have disks. And I'd like you to notice that image and disks have different definitions. So images and tags, you've got the name, image or tags, equals, and then the value. But in disks, we don't have an equal sign. This is because disks are a nested block inside a resource. It is a way for us to declare a collection of information that is interconnected. So we're going to get into deeper detail on the difference between these two things. What's important to keep in mind is from a user perspective, if you're writing Terraform configuration, all I really need you to know is blocks and arguments. That's kind of the main thing you need to know. Everything else is details for provider developers, Terraform internals. Now I've mentioned the plugin protocol. This is the wire protocol that Terraform Core uses to communicate with provider plugins. This communication is done over gRPC, and that protocol is defined in these .proto files that we have in the Terraform Core codebase. Now those files are copied into the SDKs, which are friendlier implementations of the protocol. The SDKs have some nice helper functions, lovely features, great help with testing. There's a couple of SDKs available right now. We've got the Terraform Plugin SDK. That's the main one, the one that most folks would have used. Terraform Plugin Go is a bit newer. It's a little closer to Terraform's internals. So the goal there is to give you much more power and flexibility. And then I would just like you all to be very impressed with my amazing design skills. This is an illustration of Terraform and plugins speaking over a wire, because I am not a designer, but I had fun making this. All right, so there's the basic Terraform talking to providers. Now, if we're talking about providers, Everything in a provider is defined in terms of its schema. So again, a provider configuration has a schema, a resource is defined with a schema, etc. The top-level schema container is a block. That's the same thing I said when referring to the Terraform configuration language. They both have blocks. We really like to overload words. So a block in Terraform configuration language isn't necessarily exactly a block in the schema, but it basically is. So just, yes, it's complicated. It's what we do. A block contains attributes and more blocks. So that's the nested block concept I mentioned briefly. Now I'm going to show you what the definition of the block looks like in the actual protocol. So this is a snippet of the entire schema. This is showing just what a block is in the schema. Now there's a lot of information here. The interesting details I'm looking at, a block has attributes and it has nested blocks. Those nested blocks are more blocks. Now let's talk a bit about attributes. An attribute in the schema has some basic information. So attributes are those arguments. It's got a name. I've got the type, the expected type of the attribute. Now in the SDK, an attribute can be a string, number, or Boolean. It can be a map, list, or set. I'm probably leaving something out, so let me just apologize now. Now in Terraform, a type can also be an object, although that is not currently supported in the Terraform Plugin SDK, the main one. An attribute can be required or optional. An attribute can be defined as sensitive, and it can be defined as computed. So if an attribute is computed, that means that we don't expect users to set it in the resource. It is something directly out of the provider that we store. Now, if I'm looking at an attribute in the schema, again, the interesting information I would like you to notice, we've got the type, as I've said, and then we have all those flags, required, optional, computed, sensitive. Depending on what of those flags are turned on and off will determine a lot of the behavior of the provider and how it's configured. Sorry, behavior of the resource being defined here. Now I want to take a look at some resources as they are defined using the Terraform Plugin Go SDK. Now this is from a personal implementation, so I can't guarantee that this is the best way to do things. But what I've done here is re-implement our random provider, specifically the random pet resource, which if you've seen my talks is clearly the only resource I actually use regularly. But I've got that defined in the schema, so you can take a look at what it looks like. So as I've said, my entire random pet description is a block in the schema. And then inside that block, I have attributes. For the sake of this example, my random pet attributes have a length and a prefix. So if I'm a user now and I want to create a random pet resource, this is what the configuration would look like. I've got my length and my prefix set to values. Blah. Now I'm going to go into a more complicated example. In this case, I have a made-up resource called a Happy Cloud instance. This resource is a block and it uses more blocks. So this resource, I'm showing a nested block of disks. And inside the disk blocks, I then have a list of attributes. So here I'm showing size and mount point as some kind of arbitrary examples. So now this resource, if I was going to write it in my configuration, might look like this. I've got multiple disks. A detail I'm not going to get deep into is that your blocks have a nesting mode, and that, among other things, will determine whether or not you're expected to have one, more than one, a specific number, unlimited number. So here I've got 2 disks I've created using nested blocks inside my Happy Cloud instance resource. Whew, okay, so that's all the key concepts I wanted to cover. So here's our next palette cleansing. Again, Pug, Lauren, this is for you. So here's where I come in, a couple of releases later. As I said before, that combination of the pre-0.12 flexibility, the new type system in 0.12, the complicated shims, and the new protocol all led to this fairly random assortment of problems and feature requests, along with all the good things that brought about. What I did was start with a curated list of some of our top issues and requests from the SDK team, and they'd work with the providers working at HashiCorp to come up with this list. And then with a lot of help and some creative squinting, I teased out one common component of some of the items on that list. Blocks are weird, yo. They do weird stuff. So one of my personal joys is taking on these projects that are both technically and emotionally challenging and building trust in my professional relationships. I claimed time on Terraform's core roadmap to address this, not just because there were important issues that we needed to look into, but because at the time I got to it, there was some kind of pent-up frustration and our feelings. 0.12 took a long time. Not everything got addressed as quickly we would have liked. People were concerned that we weren't following up on these issues, and I wanted to do what I can to help with that. I'm going to admit that when I carved out some time on Terraform Core's 1.0 roadmap, I was hoping I'd get to address more, but really this one problem took up all my time. I'm going to give a refresher on what we've already seen today. I've got a resource in terms of Terraform configuration language and the schema. The whole thing is a block. Images and tags are both attributes in the schema, although they're also arguments in the configuration language. And disks, while being an argument in the configuration language, is a nested block inside the schema. And again, you can see the difference is that images and tags are defined with equal signs and the disks is not, because it is a nested block. So there's some limitations to using those nested blocks inside of a resource schema. The native limitations of blocks and that kind of shim-splosion meant that blocks worked really well for most cases, but there were edge cases that led to issues. For one of them was simply that there's a different configuration syntax for end users. So it wasn't always clear to a user when they were supposed to use that block style syntax versus the attribute style syntax. It's not also always clear to provider developers. Users don't know how to index inside of a collection of nested blocks because it's not just a list that you can refer to like you might other things in Terraform. You can create multiple blocks with the dynamic construct. That's the only thing dynamic is used for, whereas other things in Terraform use for each and count. And then there's this thing called config mode adder that exists in the schema that's even more complicated, and I'm not even going to get into it, but it's yet another wrinkle that makes half of what I said not true if that flag is on. So let's just gloss over that one. There are also no block flags. When I talked about attributes, we could say that an attribute is sensitive or computed, but in a block, you can't do that. All of the items inside of a block are just there. They always have to be set by the user. There's also no zero values for blocks. So when I have an attribute like image here, I can set it to an empty string. This works. Empty disks does not actually work. You don't have a way to explicitly say, I want none of these things. All right, so with the work I did, I came up with what I would like to call the USB-C solution. And of course, what I mean by this is instead of fixing the problems with block themselves, I added yet another way to define a collection of attributes. So, hey, instead of 2 ways to do things, now we have 3. It's not as bad as all this, but it makes a good joke. So what I did is add a new field to attributes in the schema. This field is called NestedType. It is an alternative to the type. So instead of saying the type of this attribute is a string, you would say this attribute has a nested type. And inside that nested type, then you have another collection of attributes. And of course, all of those attributes can then have the sensitive, computed, optional, whatever flags you want on them. And that's really it. It's kind of simple. I'll show you what it looks like in the protocol. So here I have an attribute in the schema. This is almost exactly like what we've seen before, except now I have this new nested type field, and it's using a struct called an object. I can take a look at that object, which is rather simply a list of attributes. So, right, super easy. Like this is just nothing. I barely did anything. So not quite. I have here just a snippet of the internal proposal I wrote for the feature. It really did take me weeks first to understand the problem. And keep in mind, this is after months of our SDK team talking to the provider developers, dealing with the issues themselves, writing up the list of feature requests. So they did all of that work. I read the list and pulled out the theme. And then a few more weeks to write even just the description of the problem. I used, and am insanely proud of, the phrase, a constellation of interconnected issues. Yes, I'm so pleased with myself, I'm going to make you listen to it too. So then, after all that, when I finally thought I knew what the problem was, I workshopped 3 different versions of the protocol v6 so we could kind of figure out which was the best solution. To do this, I needed a branch of Terraform, I needed to write my own provider, and I had a fork of both Terraform Plugin Go for the protocol and the Terraform Plugin SDK because it had some really great test writing features. So all of that work and then workshopping the 3 solutions before we settled on the one that we thought was best. Now, finally, we're going to take a look at the Happy Cloud instance that I showed a schema for previously. So this is the schema we've seen before, and I'll show you what it looks like when I rewrite these disk blocks that we've, again, seen before as NestedType attributes. So again, Happy Cloud instance in the schema, Happy Cloud instance written in Terraform configuration language with a couple of disks. Here's the new schema. So now, instead of blocks, we have an attribute disks that has a nested type. And then inside that, there are attributes. What I did is add a new attribute for this example called secret key, and I've set it to sensitive. So now, if I'm rewriting my configuration with this new schema definition of a Happy Cloud instance, you can see that my disks is visibly a list of objects. So the syntax, slightly more verbose, but now I have a list. I can create it in a local using for each if I want to build up values or even assign an entire variable to that list, things you can't do with blocks. And now because secret key here was set as sensitive, if I'm doing a Terraform plan and apply, that secret key won't show up in the output, it'll be redacted. So previously, you'd have to hide the whole block or nothing. So there's some pros and cons to this new tactic. The upsides is there's a more consistent user experience. If we stop using blocks and only use nested type, there's a single syntax for every argument where you have the name equals a value. And then that value might be a string, it might be an object, it might be a list, but it's always going to have the same syntax. You're always going to index into that item the same way as you do with other collections. And we're just not going to need dynamic expressions anymore. So no more of that like bespoke single purpose tool. Downsides, of course, is that blocks still exist. So if a provider developer wants to refactor all of the resource to use nested types instead of blocks, well, they're going to have to refactor the provider, and the users are going to have to refactor their code because the syntax has changed. So that's a pain, and it's entirely possible that we're not going to see people wanting to change existing resources, only write new resources using this going forward. Now, this change, the nested type, while it did seem fairly simple, is not backwards compatible. So I did have to introduce an entirely new protocol version, which means if you write a provider using protocol version 6, it's not going to work with Terraform 0.14 or earlier. And honestly, due to some bugs, it's not going to work before Terraform 1.0. Okay? And because that older protocol and the NestedBlocks syntax is going to be supported, we've guaranteed it for at least all of the 1.x Terraform releases, they're going to be around for a while. Basically, I really couldn't create a situation where users weren't going to be required to check the documentation if syntax changes, and you still need to know if you're defining a resource basically with that equal sign or not. That's kind of what it boils down to. So there's some pros and cons. I'm hoping that over the next several months and years, we're going to see nested blocks kind of falling out of favor for this more consistent syntax. And then I'm sure more features and bug fixes will come along in the time, but I don't know what's actually going to happen in the future. So I can only hope how things are going to go. Writing this talk was more like writing a term paper, and in the end, I would have felt better giving you a 50-page essay than kind of trying to babble my way through all of these technical details. So I'm going to at least share some of the references I use, the public ones. This is nothing compared to the list of internal documents I read from, but I've got some links with information on if you're interested in writing a provider, or if you want to know more about the plugin protocol internals. There's a wonderful talk that Patty and Katie, who are both people on the SDK team at HashiCorp, gave last year that I highly recommend. That goes over the history of the SDKs from their experience. And then I also have a couple of links to some descriptions of the attributes/blocks problem that we had publicly facing. That's all I have for today. I hope you found something interesting and helpful there, and I really appreciate you watching me. Have a good one.